Thank you. Can you hear me well? Yeah, I think mic is working. Hello, everyone. I'm super excited to be here at this conference today. I normally live in London, and so first of all, it's a good excuse to visit a beautiful Krakow. And secondly, it's really refreshing to see a conference with variety of topics like this, right? Like yesterday, we have something about AI, UX, monorepo, even something around philosophy from Aga, and I love it so much. I think it's quite interesting, and we have today even more. However, in this talk, we have probably my favorite topic, some secrets how to save literally millions of dollars when you are running your backend applications on infrastructure or in clouds. I know there are also many front-end engineers here in the audience, so don't worry, those secrets apply to that front-end code as well. And that secret knowledge is not always comfortable. Not always comfortable to use, not always comfortable to follow, as it requires some discipline, some effort, some good tooling. It might help you a lot, but it might also irritate and annoy you a lot. And that's a good thing, because as you see, my talk is an oyster talk. And it's not that I love seafood. I actually love the seafood, and my wife from the audience can confirm that. The reason we can call this talk an oyster talk is because oyster has a very specific characteristics. When you damage or irritate the oyster, two things can happen. Either it dies, or beautiful, amazing pearl grows in it, right? You see, within 30 minutes, I cannot teach you why and how to optimize in all details to save that money. What I can do, I can give you general directions on how to do so and potentially irritate you so the beautiful pearl can grow. And finger crossed you will not die. Okay, so before we start, short introduction. My name is Bartek Płotka. I work at Red Hat. My background was always around software engineering, a bit of SRE, DevOps, and team leading. And I love open source, Go, distributed systems, and observability. I do a lot of projects in open source. I mentor a lot, so if you really want to join the CNCF space or Cloud Native Foundation, Computing Foundation, and you want to do more in open source, just go there and check if you can apply for some mentorship. Like even if you are a senior engineer but you never work in open source, that's your opportunity as well. And then I'm active in the CNCF as well. I also wrote a book recently. It's called Efficient Go, and this book explains all the things I mentioned in this talk in very details, all while using Golang, my favorite programming language, as an example. However, as it turned out, accidentally, majority of those chapters are not about Go, but about just software optimizations, and it's really language agnostic, so it applies to all software. So let's start with a few questions. Please raise your hand if you have ever heard about this quote. Premature optimizations is the root of all evil. Amazing, yeah, actually majority of the room. For those who haven't heard this, it comes from Donald Knuth, from his article from 1974. And by the way, I really recommend reading from time to time old programming books. They are actually undervalued. There is so much relevant information still to even relevant to modern programming. And I kind of researched for my book, and I was so surprised that they described all the problems we have right now with different patterns, with scalability, with optimizations. So really, yeah, don't ignore those. And back to the Donald, he wrote that programmers waste enormous amounts of time thinking about or worrying about the speed of non-critical parts of their programs. We should forget about small efficiencies, say about 70% of the time, so just all of the time almost. Premature optimization is the root of all evil. Why is that important, like this document and article? It is important because this quote through decades went what we would call today viral, and without TikTok, so that's kind of impressive. Essentially, every programmer was repeating this and really remembering by heart to make sure we don't waste time, programming development time, to optimize something unnecessarily. And yeah, that kind of makes sense to me at least. But so my question to you, would you agree with this statement? Would you agree with Donald that optimizations can be dangerous? Raise your hand if you would agree. Okay, almost everybody. Amazing. I agree as well. to some degree that premature optimizations can be dangerous. Unfortunately, as with all extremes, I think this is quite overused, quote. And especially nowadays in the DevOps, SRE, software development world. So let me explain why with a quick story. This happened, a few years ago in the Thanos project. So I started this project at some point with another colleague of mine in open source, and we donated it to the CNCF at some point. And generally, we have quite amazing community and user base. And ignore the build fail. Don't worry, it was just a flake, nothing important. But essentially, the main thing you need to know, it's essentially Thanos is a scalable monitoring system written in Go. It has multiple microservices and essentially stores some metrics cheaply and efficiently, ideally. And one of the component and microservice in this project is called compactor, and it's a very important component in the Thanos system. And for this purpose of this talk, it doesn't matter like what exactly it does. It is just a small server written in Go and that talks to object storage and processes some data. The point is that it's very critical to the system, and it processes gigabytes, sometimes terabytes of metrics every day. And at the very beginning of Thanos project, common thing happened. The first iteration of the project was successful. Many people deploy it, use it, and generally it was successful. But as almost with every initial implementations, it was very naive. Compactor code was a bit inefficient. It did work at the end, but it was consuming a lot of memory, like gigabytes within single seconds and so on. And we can see like clearly, suddenly it was running, like doing almost nothing, and then, for some workload, it was like spamming with almost 20 gigabytes of RAM, like within seconds, and of course that was surprising for users, and so on. And, luckily we have a nice community that was, really, finding this issue, reporting, but generally we were, coming together as a team, as a community, and trying to find solutions, right? And there were certain solutions proposed by the community that were surprising to us. And I found some pattern there, right? So first of the solution which was proposed was, let's tune the configuration, right? Some community members were asking, what is the right configuration to not have this spike of memory? And I don't know where it comes from. Perhaps, maybe certain solutions like Java, JVM, it has like so many configuration flags that you need to have AI to really tune it. And I'm not joking, like literally Google was developing some tool to like try different knobs and configuration. But it's not like every software has some magic, configuration for tuning. And it's just, if there is inefficient code implemented, it's inefficient, and like no configuration can change it. So that solution was obviously not great. Another solution was to ignore the problem, right? We can just buy bigger machine and it will be fine. And generally, it can work for some users, but it's not perfect as well. You cannot scale unlimitedly like that. There is limit to virtual machines. They cost a lot as well. And there's generally like problem if you have large heaps as well, like it's not cheap. And generally you overpay, right? If you just run this inefficient software on bigger machines, but it's still inefficient, right? Another solution is, instead of vertical scale up, is horizontal scale out. And that's the third recommendation from the community we got. Pretty fair in some cases. For example, we could shard the compactor into multiple pieces. Perhaps we could take this process, like it processes some blocks. We could split this block into multiple and schedule on smaller machines, but more of them. And the problem is, it can work. You can consider this. However, it has downsides. And some of the downsides are, again, you are adding a complexity of the distributed system. It's easy to fail, it's prone to errors, it's just harder to implement and maintain. On top of that, you still overpay. You just run inefficient software in parts on like smaller size and bigger number of machines. And on top of wasting some resources, you are adding overhead of the distributed system on top. Like generally, you overpay a lot. And yeah, you just pay more, but just with different instances. finally, another solution to this compactor inefficiency, why we are investing, time in Thanos, why we are using it. If it has so inefficient compactor, why we just not switch to different project? There are so many, right? At that point where the problem was there, some of the solutions were not existing yet, but generally that's a common flow. You check what are the competitions. Maybe I can just use different project. Some of them are open source, some of them are paid vendors. They generally do the same. They give me some monitoring. And sometimes this is a fair solution. You might need to evaluate your project. However, there are problems as well. Like, imagine huge engineering costs to migrate and learn new tools and operational model, research how it operates and benchmark it. Huge costs of migrating the data to the new tool. And what if the other tool will be inefficient in different aspect? Maybe compaction is good, but what if it's inefficient somewhere where Thanos was efficient? Like, nothing is perfect. So to sum up, all those suggestions that were proposed are fair. Like, you should probably consider them. But all of them, in this story at least, were avoiding the uncomfortable truth that the whole issue we have in the story is because compactor code was looking like this. Generally, it was very naive. It was just YOLO code that we started like for the first iteration, and no one ever benchmarked it. No one ever kind of like looked on optimizations or algorithm. Like, why that was not our first solution from the community. We were so surprised. So with all those suggestions, it turned out that the simplest solution was to simply optimize the code and algorithm, right? With some work from open source contributor from Cloudflare, he essentially changed the code and algorithm to be in place, so we were streaming more work, so we were building this kind of block on disk instead of in memory, and it was kind of fairly easy. It took like few months, but probably because of discussions, and at the end, 4 years later, Thanos still doesn't have scale up, scaled out, or different compactor. It is the same compactor, just optimized. So what's crazy in this story is that we were so close on approving and accepting significant cost to our project, significant complexity, pain, and only because someone was lazy to not optimize, right? So those are two learnings from this lesson. Software efficiency is, on a code and algorithm level matters, and it's usually more achievable than you think. And the second learning is that there is a common pitfall where we are a bit afraid of touching the code, right? And the story I presented is kind of like one of thousands I have in my career. I saw many cases where essentially premature optimization code was used a bit like an excuse to delay improving our code, delay improving quality and efficiency of our code. And that's not good, that's some extreme, right? And as we saw in the compactor story, generally, in my opinion, engineers got a bit lazy in this front. That's why I would argue we enter the era when premature scalability and premature project jumping is much bigger threat than premature optimizations. And generally, there are kind of hard consequences of that. I think this kind of premature, scalability, project jumping, and avoiding kind of efficiency work, is one of the reasons why we are overpaying in the clouds, but generally in the infrastructure. Lack of pragmatic process for efficiency optimizations and so on are important factors of that. And nothing is free, right? And especially cloud providers, they have to earn one way or another, so I'd argue efficiency matters. So let's unpack this, let's solve this. And in the rest of this talk, I would love to go through 4 ways you can think about efficiency optimizations in a better way, to not go into premature optimizations, code optimizations, but also not fall into premature scalability, for example, right? So first of all is learning about design levels, optimization design levels. So there are essentially a couple of them, and on every level you can apply some optimizations. It's really important to be aware of all of them, that we have so many options, and how to evaluate which one we should choose. First of all, we have system level, right? So those are the usual Usual solutions I would see from the community, essentially, at least in my teams, in my kind of project I was working with. So, maybe let's change the configuration, let's scale out, let's introduce, a different cloud vendor and switch to different framework. And, my favorite, let's rewrite to Rust or some other programming language. Like Carbon is pretty new language which comes out of C++. Yeah, and this is kind of a system level. Like sometimes it's necessary, but sometimes, there might be problems. Another level which we should be aware is algorithm and data structure. So this is the level where we focus on improve asymptotic complexity. So the growth factor of the runtime and space complexity, space cost based on the input. For example, switching to different sorting algorithm, right, can improve efficiency of our solution. Whereas improving code, so implementation and compilation level, can yield improvements in constant of this asymptotic complexity. So the real complexity that you can describe your runtime, in this case, in nanoseconds, for example, latency, or even space in megabytes, how much it allocates on heap. For example, making sure so if you write an implementation and making sure it allocates on stack, not on heap, that's some kind of code level optimization. Finally, you can improve things on operating system and hardware levels, right? So you could switch to different, ARM CPU processor, or you can, switch to different operating system, configure it different, add a huge pages, configure that. Like any of this can be a fair optimizations, right? But you have to be aware that you could do it. So generally, the problem I'm describing, this pattern we are seeing, is what we usually call closed box thinking. So as I mentioned previously, when we are really biased to solutions that doesn't touch the code, that treats the code as a closed box, where you don't want to open it, check what's inside, and even worse, change it, right? And there may be, I don't know, like many reasons why we have closed box thinking, but some of them are, for example, like maybe organizations have more engineers that are not very experienced in programming and optimizations, maybe patterns like DevOps and SRE, especially when the people comes from the sysadmin kind of background, like you are more biased towards like those system level improvements, high level programming language, no code frameworks, and just amount of different projects. Like all of this makes us a little bit more biased towards changing system level things. And sometimes closed box thinking makes sense, right? And maybe not closed box thinking, but rather like changing all those system or operating levels and not touching the code. And I feel the scope code changes to not get out of our comfort zone. That's the problem, right? And that's not great because almost all software is inefficient. Unless we are talking about some grep, which was written 50 years ago. It's perhaps very close to be optimal, but generally, majority of software is not efficient. And if you take any software from out of the shelf, you can expect to optimize resource like 10 times. And that was proven in many researches. So we are missing a lot by avoiding touching the code on algorithm and code level. But there's also another extreme, right? My baby thinking. It's common maybe for competitive and like less experienced engineers, developers which are biased to changing the code instead of changing other things. So that's also bad, right? This happens when they are missing big picture and maybe, they don't know where the real goal is. So that's also wrong. So let's not go to this extreme as well. Instead, what I would suggest is escaping both closed box thinking and my baby approaches and enter, open box. And my recommendation is to be aware of all 6 levels and really understand what cost is of optimizing and benefit of optimizing on each level based on your specific skills, on your organization skills and knowledge and so on. But I would not scope the implementation algorithms. So what is that mindset that would help us optimize on all levels? In my experience, I was always relying on certain flow, but I was never kind of writing this down, and only after kind of writing book, I found that there is some pattern that we could follow. It's called TFBO, which means test, fix, benchmark, optimize. And it's essentially an extension to TDD, so test-driven development, that combines the, focus on creating software that meets both functional but also efficiency needs. For those not familiar with TDD, it's an amazing software pattern where you write a test before you change your code, right? And I really love it, honestly. I use it a lot. And I wrote about this in my book in very detail, but generally, my suggestion is to do the same, to do TDD, but for efficiency after your code is functionally complete. I call it BDO, so benchmark-driven optimizations. You can first create a benchmark, and only then you should optimize, right? And actually optimize only if it's really needed, because your benchmark might say that you are totally OK. So you have to have your data for the efficiency as well. That's why we're combining those patterns together. And if you combine TDO and BDO together, you have TFBO flow. So first we test the code. If it's not functionally complete, you fix it. Only then you benchmark, test efficiency, and then assess if you are matching your requirements or not. If yes, you just release. If not, we look on the main bottleneck, right? That's important flow first. It's a bottleneck, so the component or piece of code that contributes the most to the problem. For example, the code line that allocates enormous amount of memory. This is what we should probably focus the most first. Then we try to optimize this flow, and you can choose from all the levels we described, right? And then once you try some optimization, you repeat the whole process. And this is very important, right? We always start from the first step, from the functional test, because we don't want to essentially waste time optimizing code which yields wrong results. And that happened a lot in my career. So you have to be pragmatic to be really effective and pragmatic with your optimizations. This is what I see used by experts and what I recommend. Another extremely important suggestion is to set clear efficiency goals. I call it like RAER, and I read it as RAER because rarely we have them. But essentially, the premise is that it is a problem when we follow this TFBO and really any optimization process at this point, and we don't know what are our requirements, right? When we should stop optimize or when we should even start optimizing. Because we don't do that for fun. We are paid for that to accomplish certain goals, right? To build a product. So it's not trivial. And how we decide about that, when your solution is fast or efficient enough, typically we don't have that information. So that's really a problem. And when you don't have a clear number, how fast your application should be, every optimization is premature at this point. And sometimes we have some requirements like, your code is slow, just improve it, or it has to use less memory. Those are very vague and not very helpful as well, because imagine your code is taking 20 gigabytes of RAM and you optimize that to allocate 5 gigabytes less. Is it enough, or is it okay? Is it now good? It's a stressful situation for both ends, for stakeholders and for you. So it's not very ideal. Ideal would be to have a RAER, so essentially resource-aware efficiency requirements, where ideally you have roughly a complexity or throughput numbers, like literally numbers, around your resource consumption and latency. And it's really funny because every software engineer does this complexity calculations on interviews, but generally in practice we don't use it. We never use it, right? And that's pretty sad because it's very, very useful for optimization practices. And this is very important because some of the optimizations has to be accepted deliberately, because some optimization can improve latency by sacrificing memory, right? For example, like if we add cache, might take more memory, but it's much faster, right? So there is a trade-off here, and we have to be really deliberate in what we choose in this trade-off. And here's the irritating part. I think lack of clear goals like this, and it's because procrastination. It's because we emotionally feel bad or uncomfortable defining those, because it's like setting a condition to failure. And that's my main reason why we overspend on infrastructure, because we are afraid to set those goals like on the paper. But I still would love, encourage you to kind of like set them, try to be brave and set them. You can only, I mean, and also, you know, write this on this paper and really negotiate that with the stakeholders. You can always negotiate later if we cannot like deliver this, but it has to be written because there will be more stress, more pain if you would not have those expectations, and generally, you know, stakeholder will assume some expectations on their side. So that's kind of like much worse than if you would agree on some numbers in the first place. Last but not least, we need observability. And the TFBO definitely requires observability in many, many aspects. Main ones are when we are benchmarking and when we are finding bottlenecks, right? And you can use actually any observability signals. I work on observability a lot, so I put like some kind of open source project you can just deploy like tomorrow for metric logging, tracing, profiling. This is generally what we discuss as a 4 pillars of observability. There are essentially different kind of aspects of, you know, how those data are representing your state of your machine. We don't have to discuss this, but you know, you can read that in my book. But generally, funny enough, like yesterday or 2 days ago, someone proposed 6 pillars. So this list will grow probably. But yes, my recommendation, like TLDR, use metrics to benchmark something on production or on your micro benchmark, and use metrics to really compare the results and calculate that complexity, and use profiling for bottlenecks. Like many languages has profiling built in. There is pprov format, which works across different languages. I recommend Parka, which is like a tool for continuous profiling. So it profile your application every 15 seconds. I love it. Use it every maybe not day, but a lot. And yeah, this is what really clears your perspective on what matters in the optimizations. Okay, sum up. The main takeaways is that software efficiency optimizations matter, in my opinion, and are accessible, more accessible than you think. And we talk about 4 things, right? Awareness of all optimization levels, clear goals in RAER style, follow pragmatic flows like TFBO, so test, fix, benchmark, optimize, because it tells you where you are, what's next, and allows you to not get lost. And finally, invest in observability. You don't need to have all the tools, as I mentioned, like logging, metric, profiling, and tracing, but just metrics profiling is good enough for efficiency. So yeah, that's all for this talk. Thank you. I hope you enjoy it. I hope I irritated you a little bit, so the beautiful pearl, like in oysters, will grow out of it. And yeah, you can reach me on Twitter or any kind of links, and yeah, you can also pre-order the book if you are interested. So thank you.
We still have like 5 minutes, so we have a little bit more time for some questions.
All right, the first one.
Hi, so you mentioned about using an approach similar to test-driven development to actually check your performance and metrics and that kind of stuff. So my question is, what's your approach? Are you actually changing the red-green refactor lifecycle and adding one extra step, or you are just doing it as a separate loop where you run the performance expectations or benchmarking stuff, and then you release, or and if you do it this way, then actually there can be a problem with feedback loop, in my opinion. What I mean is that you need to have full infrastructure set up, and you are not often really testing simple stuff like algorithms, right? You're not just checking performance of the algorithms. You are checking performance of integration, of I/O, and the kind of stuff, right? Like Daniel said, there is a lot of stuff happening at I/O level, for example. So my question is, how do you have fast feedback regarding these problems, right?
Very great question, yeah. So this is very important, yes. Like you you might have a numbers for your software. Let's say you have a backend and a server, and your stakeholders saying that this API should, give you a result, below 1 second, and then it is 2 seconds right now. And how do you check that? And generally, that's why this even you have this benchmark/assess, because on different levels, on system level, on algorithm level, on code level, you have different assessment, right? And this usually can be described as this micro and macro benchmarks, for example, right? So I kind of explain that in my book. They are kind of free. You can usually good for code and algorithm levels are micro benchmarking. So you have almost like a unit test that you run like single function, but that's definitely not proving anything for your RAER, which are usually on the user level, right? However, it's already improving you if you are focusing, you know that this piece of code is a bottleneck, so you focus on improving that one. So it's better for the later stage on your optimization development. Then we have a macro benchmarks, which are amazing because they are kind of fast in a way if you invest into that. If you have like a testing cluster with all those, for example, some of observability tools, and then you have like automated benchmark that just runs your server and then run artificial clients, and then you can have a fairly quick feedback if you have nice tooling for automating that. And that is much more relevant for RAER goals, because at the end, you have your whole application, might be distributed system, and you see, it's 1 second or below 1 second for, let's say, some percentile of operations, and I'm happy, I'm approving this optimization, and I'm releasing my software, right? So this is great, but macro benchmarks are not easy to deploy, not easy to create, so there are lots of caveats. And another one is testing in production. That might feel like bad, but in generally, if you don't have good macro benchmark, that's sometimes good, right? You can just, if you invest in tools which quickly release the software and revert, especially in the infrastructure cloud, like you can try on certain percentage of traffic and have really kind of fast feedback loop, but probably this is the lowest feedback loop, or like the slowest feedback loop, because you have to release the software, do the security scans, actually release it and roll out it, and then you need to wait while user actually will use this certain API. So it's not super fast, but it could be some of the ways you can do it. Yeah.
Okay. Just to be sure, macro benchmarks you're actually running. You're running it after deploying it to some test environment, right? Some test environment. Or
it depends, right? So you can have. It depends on the framework, on what product you are building. In Go, I recommend for the most the fastest benchmarks, like really do it on your laptop. Like you can totally make it fairly reliable to a certain degree on your local environment. But of course, in the perfect scenario, you would have a special dedicated setup with stable virtual machine, or ideally not even cloud, because that might be some noise neighbors. So ideally you have your server rack under your desk, and then you just offload and do those unit tests, those benchmark tests there.
But are these macro benchmarks actually part of gateway of testing gateway in terms they can block the build or merging?
That would be amazing, yeah. In practice, this is like very advanced setup if you do that, but definitely that would be ideal, right? So ideally, they are run on every PR, on every kind of change set. You run those micro benchmarks, somewhere. But typically, it's very expensive. It's really hard to pay for all of this. So usually we do that in the nightly runs, for example. So perhaps we test nightly. And then, yes, they should fit like some kind of pipeline, rollout pipeline to block them if it's not acceptable.
Thank you.
I think we have time for one more question before we leave for lunch.
Thank you for great presentation. I really appreciate the structure of it and how you summarize the problem. And I believe you are trying to be a little bit, let's say, conservative. You say that the problem you mentioned you saw in your organization. So I can confirm that I also saw this in my organization. So by induction, we can conclude that it's maybe in every other organization. When you start describing the problem, my first question in my mind was, what is the reason? And actually, you immediately saw this black box model, and it's part of the answer. Like actually, it's the answer, but it's the, let's say the first level, because then we have the question why we think this way, and you also partially answer to this, but I have some, let's say, theory that is also related to management level. And first of all, I would like to ask, what do you think about it? Like about let's say, organization culture. And also, I would like to say that I partially disagree with one small thing. You mentioned that this black box thinking may be related to people with admin background. And I believe that the problem is that actually admins can solve the problem by using, for example, system changings, but actually they try to force developers to actually fix the code. But again, we are getting back to this organization's problem.
What's your theory again? Like, because you said that I should confirm or deny your theory.
Like this black box thinking model, it's like management think. Like maybe they think they try to think outside the box, but actually they not helping. And like developers are expensive, don't waste their time. So let's scale out horizontally.
Definitely, yeah, you are right. So it's definitely an organizational issue, like on multiple levels. So usually a single developer that joins the team has not much to say. We can mentor and just show maybe this presentation or other kind of resources that maybe opens the mind on different levels. But everything starts with manager who actually makes decision if we are investing into code changes or trying a new solution. And totally, that's a problem if manager or director, they didn't program for like last 10 years and they only see amount of salaries that we pay for developers, and they are like, no, we just change, we pay for
salaries and presentation from cloud vendors that the technical solutions from cloud vendors will solve all the problems. And they say, exactly. Oh, I saw this perfectly scaling tool from Google or Amazon. This is the solution.
That's really hard to work with, right? Because you are, the director has two choices. Has to listen to this developer who's saying, oh, it will take a month, and I will have to benchmark, and then I will have to do those, negotiations, and then perhaps it might not even succeed. Versus directors, hears from vendor, yeah, we'll do it for you yesterday, right? So the marketing is much more against these developers, and I think we should just bring awareness and talk about this more and measure more things, and be aware of vendors like lying in their benchmarks and generally saying that they are perfect. But nothing is perfect. Yeah, so very good point. Thank you.
Thank you.
All right, so I think that maybe part of the problem is that if you try to solve it on the, by scaling out, it's a little bit more perceived or more sexy or something.
Definitely.
Like you can talk about it on conference.
And serverless.
Yeah, serverless. Which, by the way, you prove those people wrong because you can talk about on conference about, doing different kind of optimization. It doesn't have to be scaling out.
Yeah.
All right, so thank you. Awesome talk. Thank you.